Okay, we looked at multiplying and dividing rational expressions. Now let's look at adding and subtracting rational expressions. Before we do that, again, let's look at how to just add a straight fraction. Remember, biggest thing about adding and subtracting fractions is that we have to have a common denominator. Here we do. So we have 1/2 plus 3/2. We're going to add our numerators together. So we end up with 1 plus 3 is 4. We keep the denominator of 2. And then we simplify if we can. So 4 over 2 is actually 2. Looking at 2, we have 1/2 plus 2/5. Again, the very first thing that we have to do is look at a common denominator. We don't have a common denominator. I'm going to rewrite this so I have room to work. Because of that, then we have to figure out what the least common denominator is. So what is the least common denominator between 2 and 5? Sometimes we have to actually multiply them together. Least common denominator is 10, which means that I'm going to have to multiply both of these fractions by something that will make that denominator 10. So looks like I'm going to have to multiply by a 5. But remember, that has to be a 5 over 5 because I can't change the value of 1/2. And multiplying by a 5 over 5 is like multiplying by a 1. That doesn't change anything. What am I going to have to multiply 2/5 by? In order to get that 5 to a 10, I have to multiply it by a 2. So 2 over 2. So a lot of times, sometimes students just say, well, I'm going to multiply by the opposite denominator. So what do I end up getting? I end up getting 5/10 plus 4/10. Now I do have common denominator. I can go ahead and say 5 plus 4 is 9. Keep that denominator of 10. And there I go. Okay, let's look at 3. Again, I'm going to rewrite this just so I have a little bit more room to breathe. Step number 1, looking at those denominators, they are not the same. So I do have to find that least common denominator. This is a little bit different than 2 because 2, basically we just took 5 times 2 and we saw 10. Well, here we actually have a least common denominator that's not 24. It's something a little bit smaller. Both of them are divisible by 12. Okay, so least common denominator is what is the smallest number that they are both divisible by. 12 is better than 24 because we are dealing with smaller numbers, therefore we won't have to simplify. So again, my goal is to get that denominator of 4 to be 12. How do I do that? I multiply by a 3, which means that I have to multiply the numerator by a 3 in order for that really just to be 1. How am I going to get 6 to be 12? I multiply it by 2. What am I doing? Okay, so I multiply by a 2 over a 2. Okay, then I go ahead and do a little bit of math. 3 times 1 is 3 over 12, which is the same thing as saying 1 over 4, plus 10 over 12. Got my common denominator. Kept my numbers the same, so I'm going to go ahead and add my numerators and keep my denominator. Okay, concepts that we're going to be working with, but look what we're going to throw in there. Some good old rational expressions. Okay, understanding rational deals with fraction. Expression means that we are multiplying products of constants and variables together. So let's look at 4 and realize that it's a lot like number 1, where we do have the same denominators. So I'm going to go ahead and just add the numerators. I have 2x plus 7x. Together that gives me 9x. I keep the denominator of 5. Not too bad. Okay, 5 is a little bit different because again we don't have that common denominator. So I have to figure out what the least common denominator is going to be. Least common denominator looks like it's going to be 8. So I do want to rewrite these. That way I'm not squishing answers in here. Okay, so sometimes this already has the denominator of 8, which means the only one that I have to translate is this one over here. How am I going to get 4 to be 8? I'm going to multiply it by 2, which means I have to multiply numerator by 2. So rewriting this first piece, I'm going to have 10x over 8, and I'm adding that to 2x over 8. Okay, what do I end up getting? 12x over 8. So I added and subtracted them. But I do have to look at this and say that I can simplify. I can simplify because I see that both 12 and 8 have a common factor. They both have a 4. So I know that 12 goes into 4 3 times. I know that 8 goes into 4 twice. So my final answer on this one is 3x over 2. Okay, so simplify if we can, knowing that this is still a fraction that we can simplify out common factors. 6 is a little bit different because all of a sudden now our denominators have variables in them. So let's go ahead and look at our least common denominator. What does that mean? That means the value, smallest value that both denominators are divisible by. I don't like ending in a preposition, but I couldn't think of another way to say that. Smallest value that both denominators are divisible by. Okay, makes sense when we're dealing with just numbers, but when we look at variables, it's a little bit harder. So what is the smallest value that we can divide both of these by? It's actually x squared. Okay, because x squared divided by x squared is just 1. X squared divided by x is just x. So in our situation, our LCD is x squared. So with that in mind, I'm going to rewrite this and figure out what I'm going to do with that least common denominator. So notice what I did. I divided them. So I'm going to take my least common denominator of x squared, and I'm going to divide it by x to figure out what I have to multiply this by in order to make it x squared. So I have to multiply this denominator by x over x. Here, I don't have to do anything because I have that least common denominator. So simplifying, I have 6 times x over x squared. I'm adding that to 1 over x squared. I have my common denominators, so that means I'm going to add my numerators. Notice I technically can't really add them. I can just combine them together because I don't have like terms. And I'm going to put that over my common denominator. And there I am. So again, what we're doing is we're taking really old rules that we know about fractions, and now we're just combining them with expressions, dealing with variables as long as coefficients. Okay, so we're going to give this section a shot. Go ahead and get out your notes and vocab. Okay, objective of this section is to add and subtract rational expressions. They have their wording of how to deal with adding and subtracting expressions with like denominators. Again, we understand it's just like fractions, where if we have common denominators, we add the numerators together, so we end up with 5n plus 15, and we keep the denominator of n plus 3. Then we see if we can simplify. I see 5s and 15s and 3s, but I realize again, because of that addition sign, we can't do anything with this, except say that that is those two rational expressions added together. Okay, this is the easy part. So with this in mind, go ahead and try example or guided practice 1. Okay, not too bad. One that we want to look at real quick is 1b, understanding that when we have a lot of variables dealing with the denominator, we have to be picky and make sure they're exactly the same. 1c, adding these together, I noticed that the numerator had a y in common, so I distributed out a y, realized now we have the product of 3 plus y in both the numerator and the denominator. Cancel those guys out, and we're actually just left with y. Okay, one thing that we didn't go over in the intro was dealing with subtracting rational exponents with like denominators. We can just see this again as a little bit of the distributive property. So how I'm going to rewrite this is I realize that I'm going to have the denominator of m plus 4. My numerator is going to be 3m minus 5, and I am subtracting the quantity of 4m plus 2, which means I have to distribute that negative through. So I have 3m minus 5 minus a 4m minus a 2 all over m plus 4. and then I simplify. 3m minus 4m is a negative m. Negative 5 minus 2 is a negative 7, all over m plus 4. So same concept, just remember that subtracting means I'm adding the opposite of everything in the numerator of that second term, second expression. Realizing it doesn't affect the denominator, it just affects the numerator. So throw a negative through the numerator of the second expression and then simplify. And we're on to guided practice 2. Okay, 2a, pretty straightforward. Throwing that negative through, combining like terms, we end up with h minus 1 over h plus 1. Don't be tempted to simplify down those h's because, again, we are subtracting a 1 and adding a 1. So they have different values in the situation. Okay, distributing through 2b, we end up with 15h plus 10 over 15h minus 5. I realize that both of these actually can be factored. We can take out a 5 from each one of them, and then we can cancel out that 5, and we're left with 3h plus 2 over 3h minus 1, realizing those 3h's stay. Okay, so moving on. Sometimes we do have an additive inverse to form those like denominators. So if you remember, we were factoring. Sometimes our answers were very, very close. Our factors were very close, except we had different signs. That's the same in this situation. So let's go ahead and look at, we have a denominator of n minus 4 and a 4 minus n. These are backwards. We have the wrong sign for each one of these. The n should be positive, the 4 should be negative. So what I'm going to do, first off, I'm going to rewrite this. So again, I have some room. I have to figure out how to get this piece to have that denominator of n minus 4. Well, to do that, I'm going to multiply by a negative 1. Just by that second term, because look what happens. I keep my first term of 3n over n minus 4. That 6 becomes negative. That n becomes positive. That 4 becomes negative. And notice I just switched them around. Okay, I could have left it at negative 4 plus n, and technically my denominators would be the same. So did I change the value of that second term? No, I didn't. All I did was I changed the signs of everything, keeping it balanced. Now I have common denominators. I can go ahead and combine my numerator of 3n minus 6, and then I have now a common denominator of n minus 4. So again, if you notice that your denominators are very close, but one has a different sign change, multiply by that negative 1 numerator and denominator, and you should be okay. All right, try guided practice 3. Okay, realizing again denominator is very close, but throwing a negative 1 through that second term changes that 3 to a negative, t to a positive, 3 to a negative. Again, don't be tempted just to say that this is t. These are not products. This is the difference operation. Here, throwing that negative through the second one, I'm subtracting a negative p. So when I do combine these, because now I have like denominators, I have 2p minus a negative 2p, which is a positive 4p. Okay, that's why I kept the same operation. I just made sure I understood that that term was negative. Okay, so now we're looking at our least common multiple. That number that is the least number that is a multiple of 2 or more numbers of the polynomial. Okay, again, I call it the number that they're both divisible by. The smallest number that they're both divisible by. Okay, if you remember in the intro, we called that the smallest number and or exponent each term is divisible by. So let's go ahead and find the least common multiple of each pair of polynomials. So looking at 6 and 4, again, what is the smallest number that they're both divisible by? 12. 12 divided by 6 is a positive 2. 12 divided by 4 is a positive 3. So we know smallest number they're divisible by is 12. Now we have to look at these exponents. Again, we want to divide those exponents by something that we know we're not going to have any negatives, we won't have any exponents in the denominator. So usually that's just the highest number of exponents. So in this situation, it's x to the third. which does make sense because x to the third divided by x is x squared, positive, we're good to go. X to the third divided by x to the third is just 1. Okay, so again, when we're dealing with exponents, most of the time it's that biggest exponent. Now we have some crazy things going on here because look at this. One of these looks like it's nicely factored. The other one, that's kind of giving us a hint that we do have to factor it. So this is one where there's nothing in front. We have a coefficient of 1. We can go ahead and say what times what gives us a positive 4, added together a 5. Well, that looks like we have an n plus 1 and an n plus 4. This one I'm going to write out as n plus 1 times an n plus 1. Okay. Now's the fun part. Again, what is the least common multiple? What could I divide each one of these by in order for us to have no remainder, basically? Well, look at this. They have an n plus 1. Whoops. They have an n plus 1 in common. So we know that that is one of our factors. Okay, what's left over? He has an n plus 4. So that means that I would have to divide him by an n plus 4 in order for this factor to not have a remainder. He has a leftover n plus 1. So I have to multiply by another n plus 1. So when I divide this, if this was a denominator, if I divided this denominator, I wouldn't have a remainder. Okay, so the least common multiple of this one, they had an n plus 1 in common. There was an n plus 4 that I had to include in order to cover this denominator, and n plus 1 that I had to include in order to cover this denominator. And I call it denominator because that's what we're going to look at later. So again, least common multiples sometimes are tricky to figure out what it is they do actually have in common. Okay, but go ahead and try guided practice 4. Okay, looking at 4a, again, going straight for those coefficients, 8 and 12. What is the smallest number that they're both divisible by? 24. Then looking at the exponents, what's the biggest degree of exponents that we have to cover? Well, just 2 because they both have an n squared in common. Looking at the t's, what's the biggest exponent that we have to cover? T to the third. So that's going to be our least common multiple. 4b, we had to go ahead and factor out with an x minus 4 times an x plus 2 and x minus 7 times an x plus 2. To start with, anytime that we're dealing with binomials, go ahead and write down what they already have in common because that's what we're looking for is what they have in common. They have an x plus 2 in common. Then write down the rest of the binomials that you'll have to cover. So we have to cover an x minus 4 in order to make our denominators the same. And then we're going to have to cover an x minus 7 in order for the second term's denominator to equal the same. So the smallest denominator that we can get away with is right there. Okay, and we are going to see more of those if that is still a little bit confusing. So here, I know I was calling them least common denominator, they were calling them least common multiple. Once we start throwing them into fractions, we rename them as least common denominators. So we find that least common denominator if we are adding and subtracting rational expressions with unlike denominators. So far we've been pretty lucky, but now we have to find that least common denominator. We write each rational expression as an equivalent expression with the least common denominator as that denominator. We add or subtract the numerators, we write it over that common denominator, and then we simplify. So here we go. Looking at this first term, I'm going to rewrite it as 3t plus 2, and then I'm going to go ahead and factor that denominator. What times what gives me a negative 3, added together a negative 2. Well, that's going to be a t minus 3 and a t plus 1. Then I'm going to go ahead and just write that second term because it looks like there's no factoring involved. Okay, now I have to figure out what my least common denominator is. So first off, what do they have in common? They have a t minus 3 in common. Okay, is there anything that I have to back up? Well, I already have a t plus 1 in this denominator, so I have to include him in my denominator because he's already there. There's no way I can get rid of him. So what does that mean? That means that I can go ahead and leave this first term because it has both of the products of our least common denominator. So I do not have to change him at all. However, the second one only has the t minus 3, which means I'm going to have to multiply by a t plus 1 over a t plus 1. So what does that do? That makes me change my color so we can kind of see these different steps. They said that I'm supposed to go ahead and combine. Since I now have common denominators, I can go ahead and combine. Holy cow, this pen is driving me nuts. I have a 3t plus 2 plus a t plus 1 times a t plus 1, because I did have to multiply by that, all over my common denominator of t minus 3 times t plus 1. Right here, kids are tempted to simplify that, but realize this is a whole bunch of addition. So what do I have to do? I have to keep going because it does say that I'm supposed to combine these. So I still have my 3t plus 2. He's not causing me any problems. But it looks like I have to FOIL this out. T times t is t squared. Outsides, insides, I have 1t plus 1t is 2t's. I have a 1 times a 1, which is a positive 1, all over my common denominator. Okay, keep it organized. Now what am I doing? I'm combining like terms. It looks like I have a t, and I have a 2 and a 1. So first off, I have a t squared plus a 5t plus a 3. That's all over my common denominator. Okay, it did say simplify if possible. I am going to quickly look at this numerator and see if there's any way I can factor that. I can't. Last step, if you want to, and again, it really depends on what how picky they're looking at, we are going to have to multiply that denominator. T squared. We have a 1t minus 3t is a minus 2t minus 3. Don't cancel those t squareds and those t's and those 3's. That is exactly what we have as an answer. It could possibly stop here, or it could go there. Is that a lot of steps? Yes. Okay, is this nearing the end of our examples? Yes. So again, this is going to be a tricky concept. Follow those steps though, and go ahead and give guided practice 5 a shot. Okay, let's give this a look. Least common denominator is d squared. Okay, because again, they both have a d in common. We have to compensate for that extra d right here. So multiplying that first term by a d over a d, not touching the second term, and just combining them, this is what we get. 5b a little trickier. I know that it looks like they have a b in common, but again, we're looking at products. This is the quantity b plus 1. That's not a product. So we have to multiply the second term by the b that it does not have, the first term by a b plus 1 that it does not have. We have to do some FOILing. We have to do some distributing. We have to do some combining like terms. Final answer down here, knowing that we're not going to be able to cancel out any of that because those are not products. We can only cancel products. All right, real world application. We know that distance equals rate times time. Sometimes we actually look at that as time equals distance over rate. Okay, so just kind of keep that in mind, that we can move those constants around, those variables around, as long as we keep it even. So hang gliding. For the first 5,000 meters, a hang glider travels at a rate of x meters per minute. Then, due to a stronger wind, it travels 6,000 meters at a speed that's 3 times as fast. So we're supposed to write an expression to represent how much time the hang glider is flying. Well, we have kind of 2 parts of our little trip. So if we add part 1 plus part 2, that's going to give us our expression of how much time equals total time. Okay? So total time is distance over rate. So we want the distance over rate of part 1. We want the distance over rate of part 2. Distance of the first part of our trip is 5,000 meters. Do we know our rate? We don't. They say that it's x meters per minute. They say then due to a stronger wind, we travel 6,000 meters at a speed that's 3 times as fast. So 3 times as fast. And we know that we are combining those two. So there's our expression. But again, notice that those are two rational expressions. We want to go ahead and combine them. So how do we do that? We find our least common denominator of, they both have an x in common. We have to compensate for that 3. So how are we going to do that? We are going to have to multiply this first term by a 3. And then we're going to combine those. So 5,000 times 3 is 15,000 over 3x. We don't have to touch that second term because it already has the least common denominator. Now that we do have our least common denominators, we can add our 15,000 and our 6,000 together and end up with 21,000. All over 3x. Okay, can we go any further? Yep, we actually can, because what do these guys have in common? They have that 3 in common. So 3 goes into 3 one time, into 21,000 7,000 times. So final answer, the expression that represents how much time the hang glider is flying is 7,000 over x. Okay, so if the hang glider is flying at a rate of 600 meters per minute for the first 5,000 meters, we're supposed to find the total amount of time that the hang glider is flying. So what are they telling us? They're telling us the rate of this first part, which is x meters. So they're telling us that x actually equals 600. Well, lucky for us, we actually have this simplified down, 7,000 over x. We know what x is now. So 7,000 over 600, which ends up at about 11.7. Okay, we're going to come up here. We're dealing with meters per minute. So what is this telling us? She was in the air for 11.7 minutes. Okay, so here's the next one. If the hang glider flew for approximately 15 minutes, we're supposed to find the rate the hang glider flew for the first 5,000 meters. Okay, so what are we looking for? We're looking for the value of x in our expression. Remember, this expression equals time. They told us the time. So I'm going to rewrite our equation to understand what it is we're looking for. Okay, they tell us the time is 15 minutes. They don't tell us what x is. So we can go ahead and plug in 15 for our time, and we know we're solving for x. This type of equation sometimes is tricky because we're trying to solve for x and x is in the denominator. How are we going to do that? Well, we have to get him out of the denominator. So in order to do that, we're going to have to multiply by x on both sides. So what that does is it just flip-flops the x. We end up with 15x equals 7,000. We can definitely work with that now. Now we can go ahead and divide by that 15. And 7,000 divided by 15 is about 466.7. Let's look at what we're dealing with. X is dealing with her rate in meters per minute. So how fast was she going for that first 5,000 meters? She was going 466.7 meters, and I'm going to have to write that out, per minute. So we know that that's not miles per minute. Holy cow, she'd be going fast. Okay, these type of problems, as soon as you start seeing them dealing with rate and time and distance, write that formula down, figure out what it is you're supposed to do. Okay, sometimes it's really nice to write out that problem in words, plug in what we know to solve for what we don't know. Okay, go ahead and try guided practice 6. Okay, here it is. We know that we're dealing with the time there plus the time back. Time, using that distance formula, we know that that's distance over rate. We know our distance is 5 each way. We know the rate of the first is just r, and we know we're going 1.5 times that on the way back, and we know that that's our total time. So there's my expression they told me to write. Then I simplified it by looking at my least common denominator as 1.2, r. My first term, I had to multiply by 1.2 in order to get that common denominator. Then I added my numerators together, and there's my simplified expression. Okay, that formula is going to be seen a lot, so do know that distance equals rate times time. Very last part of this section. Again, to subtract. We already know how to subtract, and we know about least common denominators. Now we're just going to put them both together. So very first thing that I notice is that I do not have the same denominators. So I have to go seek out that least common denominator. What do they have in common? They have an x in common. What's left over that we have to compensate for? That 4. I'm going to rewrite this so I have room to work. And I know that in order to get a common denominator of 4x, I'm going to have to multiply that first term by a 4 over 4, which means that I end up with 20 over 4x. Okay, let me rewrite this. I'm going to write this all over the common denominator of 4x. So I have a 20. And I'm subtracting that from 2x plus 1. Notice I have to do some distributing here. So I have a 20 minus the 2x minus the 1 all over 4x. Okay, I'm going to have to combine like terms. So I end up with negative 2x plus 19 all over 4x. Can I do any simplifying? No, I can't simplify this 2 and 4 because I'm not able to distribute that 2 out of that 19. Okay, so again, two concepts that we still know, just don't forget that that subtraction sign basically means take that negative through that whole term. All right, a couple more guided practice to do and then we're done. Go ahead and try them. Okay, and there they are. So review of this section. When we have common denominators, all we have to do is add those numerators together, leave the denominator. If we do not have common denominators, find that least common denominator. See what it is that they have in common. Realize 7a do not have a t in common. This t is in the quantity t plus 3. So we did have to multiply by both the t and a t plus 3. If we can't see it, factor. This one actually had a y minus 3 in common. We did have to multiply by a y plus 4 in order for, if we did divide this out, we wouldn't have that y plus 4 to worry about. Okay, then simplify if can. Sometimes, again, know that maybe they're going to leave the denominator. Sometimes they're going to make you FOIL it out. So go ahead and give the assignment for this section a shot.